To answer the questions that are going to be associated with the Model 1 saturated and unsaturated solutions, we're going to need to talk a little bit about what you're seeing within this model. So one of the very first things that we're going to look at are these bulleted items over here that are on the upper left-hand corner. These are going to be our variables. And let's just go through these variables here. The first one says that all beakers contain 10 grams of water. Remember that the water is my solvent. So the water, the H2O, is the solvent that is going to dissolve the solute. Number two says all beakers are kept at 20 degrees Celsius. So all of these beakers are kept at 20 degrees Celsius. The temperature is the same. The amount of water in each beaker is the same. All solutions are stirred for 2 hours. So each of these were stirred for 2 hours. And then the solute, the identity of these particles in each one of the beakers is also the same. So those are the variables that are kept constant throughout each one of these beakers associated to this model. Now, two of these beakers can be classified as unsaturated solutions. So let's take a look at what those two beakers are. The two beakers that are classified as unsaturated solutions are going to be beaker A and beaker B. Beaker A and B, I know that they are unsaturated because there is no solid particles that are precipitating down to the bottom down here of the beaker. So if I don't see anything precipitating, down to the bottom of the beaker, I'm going to say that they are unsaturated solutions. Now let's take a look at what would be, let's say, supersaturated solutions, or not supersaturated solutions, but where we've passed the point of saturation. The point of saturation is the maximum amount of the solute that can be dissolved by the solvent. So where do we see particles precipitating down to the bottom of the beaker? We see that in D and E. You see this little pile and this little pile down here at the beaker. That means that we have gone past the point of saturation, right? The 10 grams of water can no longer dissolve the solute, so it starts to precipitate down to the bottom. So now let's take a look at what a saturated solution would be, and looking at what I just highlighted, the only thing that I didn't highlight was beaker C. So beaker C is going to represent a saturated solution. I know that beaker C is a saturated solution because I'm comparing them, or I'm going to use A and B as a reference of unsaturated and D and E as a point of, or a reference that I have passed the saturation point for the solution, the 10 grams of water. So let's look at a couple of things that could occur here. One, if I added a little bit more particles here to A or to B, then the water, the 10 grams of the water, that solvent, would technically still dissolve these extra particles that I'm putting in because they haven't reached the saturation point. If I take a certain amount of the solute and I drop it into the solution that is already saturated, then these particles are going to start to settle out the way we see in D and E, in beakers D and E. So Looking at this information and with what I explained here, you should be able to answer the questions that go along with this model.